Were you aware that landing on Venus requires neither a parachute nor a rocket engine? This remarkable characteristic of the planet was uncovered by the Soviet Union 50 years ago. It resulted from a process of experimentation and adjustment that ultimately unveiled the reality about the most fascinating destination in our solar system. This is what the Soviets discovered upon reaching Venus and the reasons they never returned. Venera represents the Russian term for the planet Venus. It also designates a sequence of 16 missions aimed at comprehending, exploring, and charting Earth's nearest planetary neighbor. Spanning from 1961 through 1985, the Venera initiative consisted of space probes and orbital satellites dispatched to Venus for planetary study and data collection. Officially, this endeavor served scientific purposes, though the political significance cannot be overlooked. It represented one of numerous ambitious undertakings by the USSR to demonstrate itself as a superior competitor throughout space race NOVE. While Mars captures most contemporary attention in the 21st century, Venus actually attracted considerably greater interest during that earlier era. What explains this difference? The Martian surface can be examined through powerful terrestrial telescopes, providing reasonable certainty that minimal activity occurs there. Apart from a small number of fringe hypotheses regarding Martian canals, scientific consensus classified it as a lifeless world. Venus, conversely, has presented a mystery spanning centuries. Earth-based observation reveals only an impenetrable, unrelenting blanket of dense clouds. What exists underneath? The presence of clouds on Venus indicates a substantial atmosphere unlike Mars, suggesting the possibility of Venusian life. The planet's closer proximity to the Sun, combined with the insulating cloud layer, would suggest elevated temperatures on Venus, perhaps a tropical environment encompassing the entire globe, covered with thick rainforests, sustaining various alien insects and reptiles, resembling prehistoric Earth. This theory held more credibility than the Martian hypothesis. Yet the scientific establishment of that period still didn't broadly accept it. The renowned astronomer Carl Sagan had already promoted the concept that Venus's continuous cloud coverage indicated a runaway greenhouse effect that had dramatically overheated the planet, meaning the world beneath the clouds would be nothing beyond a scorched wasteland. However, only one method existed to confirm this. As with every early achievement in space race NOVE, the Soviet Union pioneered the attempt to examine Venus at close range. The year marked 1961. The Soviets constructed two probes, Venera 1 and Venera 2. This constituted standard protocol during the initial decades of space exploration, launching missions in pairs, because a substantial probability existed that one would malfunction. The ambition behind these primitive interplanetary flights deserves genuine appreciation. With nothing beyond basic calculating equipment to assist them, the Russian engineers attached a rocket engine to their probe, mounted it atop a ballistic missile designated the R-7, and charted a trajectory toward Venus. They then initiated launch and awaited results optimistically. The positive outcome was that both probes managed to pass within 100,000 kilometers of Venus. The negative outcome was that both probes suffered complete system failures before arriving at their target, yielding no usable information. Subsequently, in 1962, the Americans achieved what the Soviets had not. Their Mariner 2 probe passed within 35,000 kilometers of Venus and accomplished the first close-range observation of another planet. During a 42-minute Venus scan, Mariner 2 collected substantial data regarding the Venusian atmosphere and surface from both the illuminated and dark hemispheres. The results validated Sagan's greenhouse effect theory. Mariner 2's microwave radiometer recorded temperatures reaching 490 degrees Fahrenheit, or 237 degrees Celsius on the daytime side. Mariner 2 also determined that a dense cloud layer extended from 56 to 80 kilometers above the surface. Based on this information, NASA largely chose to postpone additional Venus exploration in the immediate term, deeming it an environment completely unsuitable for either human or mechanical presence. They consequently redirected attention toward the Moon and Mars. The Soviets, however, remained unconvinced. They intensified their commitment and organized the second wave of Venera probes. They remained completely unaware of just how severe conditions were about to become. The year is 1966, and the Soviets have engineered a larger and more robust spacecraft for Venera 3 and 4. The weight now exceeds 2,000 pounds, equipped with various instruments including a barometer, radar altimeter, gas analyzers, thermometers, and a detachable pod serving as a descent module. The concept involved the descent module parachuting through the Venusian atmosphere while recording data about composition, temperature, and pressure throughout the journey to the surface. Reality proved somewhat more complex. Venera 3 suffered another system malfunction during transit, but the Soviet targeting proved accurate. So the probe still managed to strike Venus like a projectile and crashed directly into the surface, becoming the first human-made object ever to impact another planet. The USSR actually achieved a triple accomplishment in impacting near-Earth celestial bodies. They were first to crash on the Moon, Venus, and Mars. A lesson exists within that outcome, undoubtedly. If failure is inevitable, make it historically significant. Venera 4 in 1967 came nearest to complete success. The probe reached Venus with all systems operational and released the capsule into the Venusian atmosphere. From this point, the descent module successfully deployed its parachutes and drifted gradually toward the surface. This marked the first spacecraft ever to gather measurements within another planet's atmosphere. Data transmitted by the probe revealed something particularly intriguing. At high altitudes, Venus's atmosphere closely resembles Earth on a pleasant summer day. Perfectly comfortable temperature and pressure, genuinely hospitable conditions. However, as the probe descends lower, the climate grows increasingly extreme, escalating not only in temperature, but also in atmospheric pressure. Conditions deteriorate so dramatically that after 90 minutes of gradual descent, transmission from the probe ceases. Widespread belief holds that the capsule was simply compressed like an aluminum can by the atmospheric density. This established that descending into Venus resembles diving deep into the ocean, a peculiar concept to comprehend. That air could achieve such density as to crush a metal spacecraft. Armed with this new understanding, the Soviets felt nearly certain that their remaining Venera 5 and 6 probes stood no chance of reaching the surface, yet they launched them regardless. Meanwhile, NASA had dispatched another flyby mission to Venus with Mariner 5 in 1967. Though it wouldn't make planetary contact, it approached closely enough to confirm what Venera 4 had experienced, that conditions on Venus proved somehow even more extreme than originally detected in the early 1960s. With this knowledge, the Soviets launched Venera 5 and 6 consecutively in January 1969. Both probes recorded less than 1 hour of data each before meeting the same crushing fate as their predecessor. Nevertheless, the Soviet Union remained undiscouraged in their pursuits. They would simply construct even larger and more durable probes and attempt, again, for their subsequent round of Venera landing. Attempts number 7 and 8, the Soviets implemented 2 crucial modifications. First, the descent module was constructed from thicker metal with enhanced insulation, incorporating an internal titanium sphere to shield instruments from heat and padding to cushion the impact blow. Modification number 2 proved quite ingenious. The engineers sought to minimize the probe's environmental exposure duration, so they placed an additional tie around the parachute lines. This would prevent the parachute from fully opening as the probe fell through the upper atmosphere. The tie material was then engineered to melt at a specific temperature, allowing parachute deployment at a lower altitude. Although Venera 7's parachute did deploy on August 17, 1970, it still didn't endure long. The material either tore or simply melted, but either way, the landing module ended up plummeting like a stone, achieving a terminal velocity of 61 kilometers per hour before bouncing off the Venusian surface. Based on that transmission, the Earth-based observers assumed they were witnessing yet another failure to reach the surface intact. However, that assumption proved incorrect. Even with a damaged antenna, the lander continued transmitting information, and what Venera 7 discovered would validate scientists' gravest concerns. The surface temperature recorded showed 475 degrees Celsius, or approximately 900 degrees Fahrenheit, hot enough to liquefy lead and far too hot for any machine to function reliably. Yet somehow the Soviets remained undeterred. In 1972, they would repeat the entire attempt with Venera 8. Miraculously, this mission encountered no technical difficulties throughout its journey. The descent module landed gently on the planetary surface with all instruments intact and recorded for just under 1 hour. By this point, established knowledge confirmed that Venus's temperature exceeds 900 degrees. The surface pressure equals 92 times Earth's atmospheric pressure, comparable to being 1 kilometer underwater. And if that weren't sufficient, the lower atmosphere contains sulfuric acid, The substance found inside automobile batteries. One would assume all this confirmed knowledge would finally discourage even the most dedicated engineers. But the Soviet Union simply refused to abandon their efforts. That is, until they literally ceased being a union entirely overnight, the whole wall collapse situation. But we're not exploring that topic today. Where we are heading is back to Venus, because Venera 8 revealed one final fact too compelling to ignore. Even with the dense cloud coverage, sufficient sunlight reaches Venus's surface to capture a photograph. For Venera 9, the Soviets made a fundamental alteration to the probe's architecture. This becomes apparent just by examining it. Some extraordinary features are present here. The descent capsule itself has been reinforced yet again. The weight now approaches nearly 5 metric tons, but the distinctive features relate to a new landing procedure. Given everything now understood about Venus, minimizing probe exposure to the environment became paramount, and previous experience demonstrated that even after being accidentally dropped and plummeting hundreds of meters, Venera 7 still managed to operate. So what occurs if the probe is dropped intentionally? This explains the 2 rings at the bottom, actually the landing gear, or impact ring, simply a flat metal circle connected to the main body through a series of shock absorber legs. At the top sits the new aerobrake. This is how landing on Venus occurs without requiring a parachute. This component, resembling an unusual hat, is genuinely all that's needed to reduce the probe's speed sufficiently for a safe landing. It puts Venus's incredibly thick atmosphere to practical use. The atmosphere behaves more like water than air. It's remarkably strange. They did technically employ a parachute merely to decelerate the probe in the upper atmosphere, to reduce it to subsonic speed, but the actual landing itself was a free fall straight into the ground from 47 kilometers above the surface. Now, regarding those cameras, this is the first photograph ever captured of Venus. It was recorded on black and white film by Venera 9 in 1975, and what appears in the image is a field of broken, jagged rock surrounded by a sand-like material. It's not exactly spectacular. The photo is interesting solely because it was taken on Venus, but I still find it quite remarkable. This is the view from Venera 10, an identical lander that arrived merely a few days afterward. And now flat ground appears with scarcely any of those rock chunks, just the smooth surface of what was likely once an ancient lava flow. Venera 11 and 12 proved less eventful missions. They failed to return any noteworthy photos due to lens cap malfunctions. This represented one of the challenges with Venus. The camera must be protected during descent, or it will melt prematurely. But then reliance falls on an automated system to expose the lens, which didn't consistently function. Venera 13, an unlucky number but a highly successful mission in the year 1981. This probe returned the first color photograph of the Venusian surface, and it ranks among my favorites. Once again, the surface surrounding the lander consists of flat, sandy rock, but you can observe just a hint of landscape beyond. The probe landed near a cliff edge or a hill peak. You can perceive a sense of depth that makes everything seem simultaneously more authentic and more alien. Scenes like this should inspire every person to appreciate Earth a little more, as most planets and moons in the galaxy probably resemble Venus. All the ones discovered thus far anyway. Barren, lifeless rocks. You can also observe the lander's base again here, and what purpose do those teeth serve? They appear almost deliberately menacing, but the teeth fulfilled an aerodynamic function. Metal teeth were added to the impact ring's perimeter in an effort to minimize spin and oscillation experienced by previous missions 11 and 12, which could result in quite a rough landing. But that's not all Venera could accomplish. The probe was also equipped with a drill and surface sampler to analyze the Venusian soil, and what it discovered was material very similar to a rock we call tuff on Earth, essentially just solidified volcanic ash. Oh, and one additional feature. Venera 13 carried a microphone, enabling us to hear the sounds of Venus. It's essentially wind noise and the sound of the probe conducting its operations. But again, like the photographs, there's something profoundly eerie and alien about it. Venera 14 was again nearly identical. It discovered another flat plane of these smooth rocks, which were determined to be very similar to tholeiitic basalt, a volcanic rock composing most of Earth's ocean floor, and that concluded it. That marked the final time a human-made object reached Venus's surface. Some genuinely impressive work was accomplished with balloons, but that's an entirely separate story. What I want to examine here is why we never returned. One very obvious reason would be that it demands substantial work and expense for relatively minimal return. You can dispatch a robot to Mars and it will operate for years, whereas the longest Venera ever functioned was approximately 2 hours. The Venera program concluded right as the Soviet Union itself was ending. Leadership and priorities shifted. Russia experienced a difficult period during the 1990s. We're also confronted with this paradox. As our technology grows more advanced, it simultaneously becomes more fragile in many respects. The old Soviet Union represented the ideal environment to construct a machine capable of withstanding Venus, and we may have lost that style of craftsmanship in the pursuit of ever cheaper and more efficient manufacturing. I observed an interview on television recently with a veteran NASA engineer, and he was discussing the Voyager 1 probe. He drew the analogy that Voyager's computer was approximately as capable as a 1970s pocket calculator. Today we can carry the computing power of an iPhone in our pocket, but does anyone genuinely believe we could launch an iPhone into space and have it still operating 40 years in the future? Apple updates alone would render that impossible. However, much remains to be learned from the past if we genuinely wish to advance our space exploration into the future.